Okay, the other type of network you might find for short-range communication, um, and there have been several different variants of these. They're called wireless personal area networks. Very short range, 30 feet or less. Probably the predominant network that you're familiar with in this category that's kind of replaced everything else. Just kind of like Wi-Fi has replaced some of the previous protocols for home networking, and the personal networking. Bluetooth is predominant. It was originally proposed to replace actually serial cables, so that you could ideally just have a single power cable connected to your computer, and then everything else could communicate wirelessly with Bluetooth keyboards, Bluetooth mice. You could connect to a printer via Bluetooth. Um, all of that is possible. So it was designed to get rid of all of the serial cables that you have connected to your computer. Of course, it's pretty. You see it these days for Bluetooth headphones to connect to smartphones, and then also there's a predominance of Bluetooth speakers for playing music. Again, typically from your cell phone, or perhaps from a smart speaker. So the corresponding IEEE standard is 802.15.1. The IEEE has, and it's the 802.15.1 that is known as Bluetooth. IEEE has developed other personal area network standards in the 802.15 series, 802.15.3 and 802.15.4, which I'll comment on briefly. Um, 802.15 personal area networking. Again, Bluetooth is the 802.15.1. There's an 802.15.2, and then 3, and then 4. But again, for the personal area networks, the Bluetooth standard is the predominant standard. It's used for short range radio frequency communication, low cost, low power, radio based short range. Again, typically less than 10 meters. Radio technology is built into the cellular telephone. Most laptops come with Bluetooth radio as well. You can also find printers that have Bluetooth connections. Although there again, you're seeing Wi-Fi printers become more available than Bluetooth printers, as Wi-Fi appears to have the corner on the home network market. So Bluetooth can actually be used in a couple different ways. It can be used to connect um, a laptop to a cellular network in an ad hoc network. It can be used, this is the traditional configuration, where you've got a central master computer connected to, and with the Bluetooth standard you can have up to 7 slave devices. So here they show Bluetooth connected keyboards and printers, headphones, joysticks. It can also act as a bridge to other networks, via the cellular network, or you can use it as a bridge to your internet connection as well. You can also form an ad hoc network to transfer files directly between devices over Bluetooth. Uh, this capability is built into most laptops, but again, I think most people end up, if they want to transfer files between computers, they end up doing it via their internet connection and using Wi-Fi instead of Bluetooth. Again, you can transfer files from your phone to your computer directly. I don't know. I've always thought the steps you had to go through were a little clunky, and it just may be that so much much more used to transferring files over over the internet than using Bluetooth. But it seems like you have to go through extra steps, and you know, you're so familiar with already transferring files via the internet. So the arrangement where there's one master and several slave devices, up to 7 slave devices, is what's called a piconet. Again, this is just another example of a piconet with one master device and multiple slave devices. The intent of Bluetooth was, again, to eliminate wires, and has a typical range of 10 meters, or the other rule of thumb is it's about 30 feet. Bluetooth actually, I think a single packet length in Bluetooth is 625 microseconds, and the basic bit width is 1 microsecond, so it's 625 bit widths. But Bluetooth allows you to actually request 1, 3, and 5 slot packets, so you can transmit a lot more data and achieve higher data rates with a 5 slot packet. So it uses a time division multiplexing scheme among all the different devices, but the high data rate devices can request and use up multiple packets. There's different types of they're kind of like physical links, but it's all done using packets. There are what are known as SCO links, which is for synchronous connection-oriented link. Again, that's kind of like the TCP connection, where you have to maintain a connection. And then there's the asynchronous connectionist link, or ACL link, where polling is used to determine which devices need to pass data. And there are a number of different packet types for the two different link layers, the SOC and the ACL layer, and the different packet types can actually support different data rates. Some actually offer error correction, others do not. Again, so some similarities here to TCP and UDP, where we have error correction built in. Here's some of the core protocols again. The number of bytes that can be handled with the different packet types, you know, whether it's they include forward error correction or not, and then also the different data rates that are possible. Excuse me. So some of the features of Bluetooth: it uses a fast frequency hopping method to reduce interference. Adaptive output power, which means devices can that are close can reduce their power level to maintain a longer battery life. It can use short data packets. Fast acknowledgments of packets allows for low coding overhead. There's a number of different packet types that are available for with a number of corresponding different data rates. It's a good technology for transmitting of voice or audio, so that's why you see it's used so commonly with Bluetooth headphones and Bluetooth speakers. It can support the corresponding data rates. And then again, the transmission reception can be customized to minimize the power consumption. Bluetooth radio typically hops faster and uses shorter packets compared to other systems operating in the same frequency band. Some of the protocols actually use, again, forward error correction, as if there is a lot of interference, then the performance correspondingly decreases. Bluetooth devices interact with other Bluetooth devices. One's in a master-slave arrangement. It's called a piconet. Again, you can also have kind of what's called an ad hoc network, where there's no one well-identified master, but in a piconet there's a master and then several slaves. The single channel radio channels shared among all devices, again in a time division multiplexing device. Each of the slaves has an active member, 3-bit active member member address, again with 3 bits. You can address up to 8 devices. That's why you have the 7 slave limit. A lot of other slaves can remain synchronized to the master because you can park a slave, make it inactive, and then communicate with others. So that's one way around the 7 device limit, is actually to park a device. If piconets are close to each other, they can have overlapping areas, and if you have 2 or more node piconets overlapping, the result is what's called a scatter net. Before any connections in the piconet are created, all devices are in standby mode, and then in this mode an unconnected unit periodically listens for a message. Okay. So here's some of the characteristics of Bluetooth. Operates in the 2.4 gigahertz frequency range, which is an unlicensed FCC band. So it's used by several other devices. It uses a spread spectrum technique, and it's intended for short range communication, so it won't interfere with other devices. It has limited transmission power and range. There is a limit on the number of devices, and it's intended for relatively low data speeds. Not like the megabits per second we can get with our Wi-Fi and wired Ethernet connections. So the maximum number of voice channels you can have is 3 per piconet and up to 7 data channels. Let's see. Price for a Bluetooth radio add-on here is predicting less than $5. It's well below that now. Okay. Again, a scatter net is just consisted of multiple piconets. You can actually have devices belong to 2 piconets simultaneously, so you can have bridges actually between the different piconets. And this is another example of a scatter net showing some devices belonging in slave devices in multiple networks. So more details on packet transmission. The channel is divided into 625 microsecond slots with 1 bit per second. 1 bit per microsecond, so 625 bit time periods essentially in a slot. But some of the devices can actually access multiple slots. So no device actually gets the 1 megabit rate, again because it can be shared by up to 7 devices. So the maximum rate for any one Bluetooth device using 5 of the slots is 400 and some kilobits per second. So security is a feature. Bluetooth devices use a combination of a personal identification number. Again, because of the short range, typically you've done this, I'm sure, with perhaps even it's common to have Bluetooth technology in your automobiles to connect your smartphones to your radios, and then there you typically have to go through the procedure of pairing your smartphone to the radio, often with a built-in PIN number. But for a little more security, you can change that PIN number. Of course, typically for these short-range networks, someone needs physical access to the device to press a button or something to complete the pairing. The same is often true for pairing a smart speaker to a cell phone. Frequency hopping helps to eliminate some of the interference that might typically occur with multiple devices all operating in the same range. And this this picture shows what's called a blue star network, showing piconet connected devices, then all connected to Wi-Fi, and then ultimately the internet. So providing internet connectivity through Wi-Fi, and then all your Bluetooth connected devices. And this, again, may or may not be common. I don't know. Some of you may have Bluetooth mice or Bluetooth keyboards, or perhaps even a Bluetooth printer. But typically, with a lot of printers now, I find that they're Wi-Fi capable, so that you can print from any computer in your house or your smartphone, as opposed to having a Bluetooth connection to a master computer. Again, the IEEE has come up with a couple of other standards that are intended for the personal area communication. There's the 802.15.3 and 802.15.4. Again, these primarily provide some higher speeds, different capabilities than Bluetooth, but overall roughly similar to in terms of possible data rates as Bluetooth. Certainly, the Bluetooth network has become the other predominant wireless standard, and then 802.15.4 is intended for low rate, low power personal area networks. So and this is just comparing the different technologies, the original Bluetooth, the 802.15.3. Let's see. So Bluetooth, the maximum data rate, 1 megabit per second. For 802.15.3, higher data throughputs, 11 to 55 megabits per second. And then the 802.15.4 is 2040, 250 kilobits per second. So lower data rates than even the 802.15.1. And then the Bluetooth 3.0, I think they're actually up now to Bluetooth 5.0 in terms of the specifications. But when this came out, the Bluetooth 3.0 high speed provided a maximum data rate of up to 480 megabits per second. And then now in the last couple years, they've come out with a Bluetooth low energy, which isn't covered in this set of slides. But most of the Bluetooth low energy devices, and it's an incompatible protocol with the original Bluetooth, but most of the Bluetooth low energy devices also provide support for traditional Bluetooth. So you can mix and match your low energy devices with traditional Bluetooth devices, as long as the master supports traditional and Bluetooth low energy. Okay, I think that's it. All I'm going to cover in this lecture. I think completing the chapter, we'll talk about some other short range radio networks. I think the next topic in this particular chapter talks about the Zigbee sensor network.